Let's be honest, moving to the cloud is exciting. It promises flexibility, scalability, and the ability to innovate faster. But here's the catch. 80% of organizations report at least one cloud-related security incident each year. Why? Because many dive in without the right preparation, leaving their systems vulnerable to things like misconfigurations, identity mismanagement, and runaway costs. So today I'm going to guide you through many of the most important considerations when building a cloud environment that's not only secure and scalable, but also efficient and future-proof. And by the end, you'll have a framework that supports your business growth without sacrificing control or security. All right, so starting with a blueprint is crucial. Imagine you're constructing a skyscraper. You wouldn't just wing it, laying bricks without a plan. In cloud computing, your blueprint is infrastructure as code, or IAC. Manual configurations might seem convenient, but they're prone to human error and they're tough to replicate. IAC tools like Terraform, AWS CloudFormation, and Azure Bicep let you automate and codify your infrastructure setup. But what makes IAC a game changer isn't just its consistency, it's the agility it provides. So let's say your team needs to replicate an environment. Instead of spending hours tweaking settings manually, you can deploy an entire stack with a few lines of code. This is especially important as your business scales, ensuring that every environment from development to production is consistent and secure. Now, if you're thinking, how do I know that my IAC templates are secure? Well, this is where tools like Checkov or Terraform Compliance come in. They scan your templates for security misconfigurations before deployment, catching issues like open storage buckets or overly permissive IAM roles. So now about account structure. Many businesses start their cloud journey with a single account setup. It's simple, straightforward, but as your needs grow, it quickly becomes a liability. Imagine running your development, testing, and production environments under the same account. An error in one environment could spill over and compromise another. A better strategy is to adopt a multi-account structure. This isolates workloads, minimizes the blast radius of security incidents, and simplifies cost tracking. For instance, you can keep sensitive data in a production account while development and testing happen in separate accounts. Tools like AWS organizations and Azure management groups help you manage this complexity by enforcing policies across accounts. And here's the kicker. With service control policies, or SCPs, you can prevent risky operations like opening public access to sensitive resources, ensuring guardrails are in place from the start. So let's talk about security and compliance. Once you've set up your account, the next step is ensuring that every deployment follows your security and compliance guidelines. This is where policy as code tools come into play. So think about tools like AWS Config or Open Policy Agent as your automated compliance officers. They continuously monitor your environment, flagging any resources that deviate from your policies. Let's say someone deploys a storage bucket without encryption. Instead of discovering this during an audit, AWS Config can flag it in real time and even trigger automated remediation. This proactive approach saves time, reduces risk, and keeps your environment in line with your organizational standards. So our next topic is going to be network design. It can make or break your security. Networking isn't just about connecting services, it's your first line of defense. A poorly designed network can leave you exposed to attacks, while a well-architected one keeps your data safe and your systems resilient. The key here is segmentation. Start by separating your resources into public and private subnets. Public subnets handle internet-facing components like web servers, while private subnets are reserved for internal resources such as databases. By using network ACLs and security groups, you control who and what can access these resources. For an added layer of protection, consider using web application firewalls, or WAFs. They're like bouncers for your web applications, blocking common threats like SQL injection and cross-site scripting attacks before they can do any harm. In cloud security, trust no one, not even yourself. So let's dive into one of the most transformative security models in cloud computing, zero trust. Unlike traditional security models that assume that everything inside the network is safe, zero trust operates on a strict never trust, always verify principle. And here's how it works. Every request, whether it's coming from an internal service or an external user, is treated as potentially malicious until proven otherwise. So this means continuous authentication and authorization for each interaction. Zero trust also involves microsegmentation. Instead of having broad network segments where services can freely communicate, you break them down into smaller zones, each with its own set of access controls. For example, your payment processing service shouldn't be able to communicate directly with your customer data service unless explicitly allowed. So to implement zero trust, start with strong identity management. Tools like AWS Identity Center, Azure Active Directory enforce strict access controls. But identity isn't just about users, it's also about devices. Enforcing device compliance policies ensures access is granted only when both user credentials and the connecting device meet security standards. So even if an attacker obtains valid credentials, they can't access the system from an unverified or non-compliant device. Compliance checks verify security measures like updated OS versions, encryption, and antivirus software. Tools such as Azure AD Conditional Access block or limit access for devices failing these checks, adding a critical layer of defense against threats like phishing and credential theft, which really reinforces the principle of never trust, always verify. So let's talk about one of the critical components of automation, and that's tagging. It's more than just labels. Tagging is often seen as a nice to have, but in reality, it's a critical practice for managing your cloud environment. By tagging resources with metadata like environment, production, or owner, finance, you create a system where everything is easily identifiable and trackable. But the real power of tagging comes from automation. Imagine a policy that automatically shuts down any untagged resources to prevent cost overruns. With proper tagging in place, you can enforce such policies effortlessly, ensuring you only pay for what you need. All right, encryption. It's not optional, it's essential. Data breaches are costly, not just in terms of fines, but also reputation. One of the simplest yet most effective ways to protect your data is through encryption. Whether your data is at rest in a database or in transit across the network, it should always be encrypted. Cloud providers offer managed encryption services like AWS KMS and Azure Key Vault, which handle the heavy lifting for you. But don't stop there. The rise of quantum computing poses a new threat to traditional encryption algorithms. Forward-thinking organizations are already exploring quantum-safe encryption to future-proof their data security. So what about secrets management? Hard-coding secrets like API keys or database credentials into your applications is a disaster waiting to happen. All it takes is one leaked code base for these secrets to fall into the wrong hands. So the solution is using a secrets management tool. Services like AWS Secrets Manager or HashiCorp Vault securely store and manage your secrets, automating rotation of keys and credentials. This ensures that even if a secret is compromised, it has a short lifespan and can't be exploited long-term. Let's talk a bit about observability now. So when something goes wrong in your cloud environment, and it will, you need more than just an alert, right? You need a system that helps you understand the why that the failure happened, right? And this is where observability comes in. By combining metrics, logs, and traces, observability tools like Datadog or Prometheus give you a complete picture of your environment. With distributed tracing, for example, you can track the flow of a request across multiple services, pinpointing exactly where a failure occurred. And this not only speeds up troubleshooting, but it also helps you optimize performance proactively. So far, so good. We've looked at a lot of critical architectural and security considerations, but are we keeping your CFO happy? Cloud billing can feel like an unpredictable storm, but it doesn't have to be. By adopting FinOps or financial operations, you can align your cloud spending with business goals. Start by creating dashboards that provide real-time visibility into your costs. Tools like AWS Cost Explorer let you break down expenses by service, environment, or team. But visibility is just the start. Automating cost-saving measures like shutting down idle resources or right-sizing over-provisioned instances ensures you're not wasting money. And with tagging, you can attribute costs to specific projects or departments, holding teams accountable for their cloud usage. So everything's humming along and we're seeing cost benefits, but then disaster strikes. Good thing we're going to talk about disaster recovery now. It isn't just a backup plan, it's a necessity. No system is immune to failure, which is why a solid disaster recovery plan is crucial. Start by defining your recovery point objectives, or RPOs, which is how much data you can afford to lose in a disaster, and your recovery time objectives, or RTOs, which is how quickly you need to be back online. Cloud providers offer services like AWS Backup and Azure Site Recovery to automate and streamline your DR processes. But having a plan isn't enough. Regularly test your DR scenarios to ensure your team knows how to respond when disaster strikes. And you want bonus points? Test resilience through chaos engineering. One of the best ways to build a resilient system is by deliberately introducing failure. And this might sound counterintuitive, but it's the essence of chaos engineering, right? Tools like Gremlin let you simulate real-world failures like a server going offline to see how your system reacts. These tests help you identify weak points and ensure your environments can handle unexpected disruptions without significant downtime or data loss. So you've now got the blueprint for a secure, scalable, cost-effective cloud environment, but there's still more to explore. You're probably wondering, well, how do I actually migrate workloads into these new cloud environments? So in this next video, we dive into cloud migration strategies covering how to move workloads efficiently while minimizing risk and downtime. Ready to take the next step? Click here to keep your cloud journey on track.